Hello, MAT112 students. We're just going to take a little survey through section 6.2 through 6.5, which kind of all have this to do with the same thing as 6.1, that is using trig identities to simplify expressions or to verify more complex identities. I put a couple of files on Moodle for you. If you scroll down to chapter 6, I put a trigonometric identities page. So this has all of the trig identities in one file. It's basically 2 pages. You can print it out and have it on the front and back of one page. From all of chapters, section 6.1 through 6.5. And then I also have this file here, which is it's kind of 5 strategies to use as we go through this. I want to show you that. So as you can see here, here are all the trig identities kind of laid out according to section and according to type. So in 6.1 we have the ratio and reciprocal identities, the Pythagorean identities, and the odd and even identities. 6.3 we get into the sum and difference identities and cofunction identities. 6.4 we get into double angle and half angle identities, and 6.5 we get into product sum identities. And then here's the strategies, a set of strategies you can kind of use. Strategy 1, if you're verifying an identity like one thing equals another, just work on one side of the equation, either the left side of the equal sign or the right side of the equal sign. Usually you're going to choose the more complicated looking sign, the more complicated looking side. And you're trying to get that complicated side to reduce down so that it is identical to the other side. Strategy 2, some expressions can be simplified quickly if they're written in terms of sines and cosines. Strategy 3, to convert one rational expression into another. A rational expression is just a fraction. So if you have a fraction involving trig expressions, basically you can cross multiply. So if you have one fraction equals another or something like that, you can cross multiply across the equal sign to try to get these two things to become identical. And then you could, after you cross multiply, start simplifying things using the identities and try to get the two things to be identical. That's one way to do it. Strategy 4, if the numerator of a rational expression, in other words a fraction, is a sum or a difference, convert the rational expression into a sum or difference of two rational expressions. That means that if you have, like, let's just say a kind of complicated fraction, you can split that fraction up into two fractions. You can split the numerator. You can't split a denominator, but you can split a numerator. We can write that as sine over tangent plus cosine over tangent. And that's the same thing as that. And then we can try to work from there. Okay. And strategy 5, if a sum or difference of two rational expressions occurs on one side of an equation, then find a common denominator and combine them into one rational expression. So if you have, let's say, sine over cosine plus cosine over sine, you could combine these into one single rational expression by getting a common denominator. So you'd have to multiply these denominators by each other, and you'd have to multiply the top by whatever you multiplied with the bottom, and then you could get a common denominator and combine them into one single fraction. And that might be a way to go as well. But there's also kind of no substitute for experience here. Just the more you do it, the easier things will become. And also no substitute for familiarity with the various identities. So look over the identities page, and then as you use those various identities in the different sections, you're just going to get better at it with more experience, which is like most other things in life. All right, so I'm just going to kind of pick out 3 or 4 problems from each section, from each homework, and work those out for you. And hopefully that'll just give you some methods to go by, just kind of a way to think through these so that you can work through the others as well. So let's just take number 1 on 6.2. Immediately, what I'm thinking is I can get these things in terms of sine and cosine. So cotangent can be rewritten as cosine over sine, and then it's times sine, which those will then cancel, and you're just left with cosine. So that's how we can reduce or simplify that expression. All right, let's look at number 5. Again, I'm thinking get things in terms of sine and cosine. So say you had cosine here times cosecant is, that's 1 over sine. And so I'm just working on the left side here. And so if I do cosine, that then becomes cosine over sine. And so cosine over sine is cotangent. So you got cotangent equals cotangent, and you're done. So out of these multiple choices, which one of these choices goes through that same process? Well, it's not choice A because it changed cosine into sine over cosine, and so that's just not right. B, cosine cosecant turns into cosine times 1 over sine. That's looking good. And then that becomes cosine over sine, and then that becomes cotangent. That's exactly right. B looks like the right choice here. Let me just look at the others to make sure. No, this is not right. Cosine doesn't become sine. Cosine doesn't become 1 over cosine. So all the other choices don't make a whole lot of sense. So choice B is correct. All right, I'm looking at number 10 now. I'm looking at the left side. It looks like the more complicated side. And I'm thinking that maybe I will want to go ahead and square that expression by multiplying that expression with itself, distributing it with itself. So that's going to be 2 plus tan times 2 plus tan. So that's going to be 4 plus 2 tan plus another 2 tan, so plus 4 tan plus tan squared minus secant squared equals, okay, so let's see what happens with that. Now I'm looking here and I'm thinking tan squared and secant squared, that seems like it might be a Pythagorean identity. And I'm remembering that 1 plus tan squared equals secant squared. So if I move the secant squared over here and move the 1 over there, that gives me tan squared minus secant squared equals 1. And so since tan squared minus secant squared is exactly what I have right here, this can just be replaced by 1. So that gives me 4 plus 4 tan plus 1. And so then 4 plus 1, excuse me, I did mess something up here. When I move the 1 over here, it becomes a negative 1. So I needed to write that as a negative 1. And so this is not going to be right. That's replaced with a negative 1. So it's 4 plus 4 tan minus 1. And the 4 and the minus 1 becomes 3. So it's 3 plus 4 tan, which is the exact same thing as that. Now let's look at the choices. I'm liking A. A looks pretty good. 4 plus 2 tan plus tan squared minus secant squared becomes 4 plus tan minus 1 becomes that. Yeah, A looks really good. Let me see it, look at the others and glance at them real quick. This is wrong because that part's wrong. This is wrong because it put plus 1 instead of minus 1, which is almost like the mistake that I almost made. Again, that term is wrong. So choice A is correct. Looking at the last one on 6.2, this is number 14. This is a pretty tricky looking one right here. Let me just see what I can do. If I've got cotangent and tangent, I know I can establish those in terms of the other. So let me rewrite this as ln of 1 over tangent, which is the same thing as ln of tan to the negative 1. And remember that the properties of logs, you have the power property, which says that the exponent or the power of a log can come down to the front of that log, so that becomes negative 1 ln tan, which is exactly what we have on the other side of the equation. So it really wasn't that hard, but it definitely looked pretty tough, and you had to kind of have remembered this part of log properties to do it. So let's see which one of these choices accomplishes that. A is looking really good. B is not right because the negative sign is supposed to come in front of the log, not in front of just that part of the log. This is not right. Cotangent is not 1 over 1 minus tangent, so that part's wrong. So choice A it is. Okay, continuing on, we're now in 6.3. Just going to do a few problems here. Number 1, sine and what are cofunctions? Sine and cosine are cofunctions. That means that they can be each other if you just shift them, shift the phase. They can just become the same as one another. All right, so if you remember, the cofunction identity is if I can get to the right file, cofunction identity says that sine of pi over 2 minus the angle equals cosine of the angle. So if we do it in degrees, it's sine of 90 minus whatever the angle is. This is the same thing as the cosine of the angle. So sine and cosine are equal if the angles are complementary of one another. So the complementary angle to 54 is, what is that? Is that 36? 54 plus 36 is 90, I think. So let's put 36 in there and just make sure I'm doing my adding, that I can add and subtract correctly, which I can't always do, and that is correct. Secant and cosecant are similar, so you just do pi over 2 minus pi over 9. So let me do that. May have to get you a common denominator there. Pi over 2 minus pi over 9. Let's multiply them by each other. And we get 9 pi over 18 minus 2 pi over 18 equals 7 pi over 18. So it should be 7 pi over 18 should be the answer. Let's type that in. 7 pi over 18. And it is correct. All right, here we have our first sum and difference identity problem. These are some that I'm not extremely familiar with, but sine of, I'm just looking at my sum and difference identities and see which one matches this. This looks like a sine of alpha cosine of beta plus cosine of alpha sine of beta. Sine of alpha cosine beta plus cosine alpha sine beta. This one right here appears to be one that will work for us. So that is equal to sine of alpha plus beta. So this will be the same thing as, sine of 54 plus 36, which is sine of 90. And sine of 90 is 1. So 1 should be the answer. Let's see if we get that as a correct answer. We type it in. It should be 1. And it is. All right, let's go on to some different kinds. Let's go skip all the way to number 10. All right, so on this one, there's something weird going on. Sine 5 cosine negative 25 plus cosine 5 sine 25. So the alpha beta thing doesn't work as it's written, but we can remember the even identity where cosine of negative alpha equals the same thing as cosine of alpha. For an even function, that's the case. So we can just replace that with just a positive 25, and it works the same way because of the even function identity. So now it's sine alpha cosine beta plus cosine alpha sine beta. I go to my sum difference identities. Sine alpha cosine beta plus cosine alpha sine beta. So it's the same thing as last time. And so we get that this is the same thing as sine of alpha plus beta. So this is the same thing as sine of 5 plus 25, which is sine of 30. And if I remember my special triangle correctly, remember this special triangle? 1, 2, square root 3, that's a 60, and that's a 30. So sine of 30 is root 3 over 2. Oh, I got this in the wrong spot. That's a 60. Let me rewrite that. That's a 60 right there. And that's a 30 right there. So sine of 30 is 1 over 2. And so 1 over 2 should be the correct answer here. Let's type it in and see. 1 over 2. That is correct. Let's skip to number 15. This looks like a pretty tough one, but let's see what we can do with it. I know that this can be replaced with the sum and difference identity. That this is the same thing as sine alpha cosine beta. Let me look back. Plus cosine alpha sine beta plus cosine alpha sine beta. So let me rewrite it like that. So you got that now over cosine alpha sine beta. Now I'm going to split up the numerator. So this becomes sine alpha cosine beta over cosine alpha sine beta plus cosine alpha sine beta over cosine alpha sine beta. And I see something quick we can do. These things cancel each other out, so that just becomes 1 over 1. So this whole thing just becomes 1. Now what about this? I've got, oh, look at this. That and that. I can write those as, that can be sine alpha over cosine alpha times cosine beta, sine over sine beta. And here we got sine over cosine and cosine over sine. This is tan alpha. This is cotan beta. So we've got that. We've got exactly what we need. Tan alpha, cotan beta plus 1. That's the same thing we got right there. So let's see if which one of these choices. That one's not going to work because that part's wrong. Sine alpha, cosine beta. That's not going to work because it's not a minus. Let's go sine alpha, sine. That looks good so far. That looks really good. Choice C is looking nice. Choice D looks like it could be in the running as well. Okay, that one's looking good too. So now I'm having trouble seeing the difference. I think D is correct actually, and C is wrong because of one little thing. Look, this denominator, when it was rewritten, was not written correctly. It's supposed to be cosine alpha sine beta, and they wrote it as sine alpha cosine beta. That part's wrong. Choice D is the right one. All right, continuing on, now we're on 6.4. Double and half angle identities is what that's mainly about, I think, if I remember correctly. So we're told to use a half angle identity to deal with this problem. So let me look at my identities and go to the half angle identities. And here is my half angle identity. Cosine of alpha over 2 equals plus or minus the square root of 1 plus cosine alpha over 2. So, okay, let me see if I can remember that. Plus or minus over 2 equals plus or minus square root of 1 minus cosine alpha over 2. Now, did I get that right? Let me look back. 1 plus cosine alpha over 2. So this should be a plus. Okay. Hopefully, let me look back one more time and verify that I've got that right. Yep. Okay. Now we're ready. So 22.5 is half of what? It is half of 45. So cosine of 45 over 2 equals plus or minus the square root of 1 plus cosine 45 over 2. And cosine of 45, we've got to remember what that is with our special triangle. Isosceles right triangle. These are equal, so 45, 45, 90, that's a 1, that's a 1, that's a square root 2. So cosine 45 is 1 over square root 2, or root 2 over 2. So this is plus or minus the square root of 1 plus root 2 over 2 over 2. We get a common denominator right here. That's going to be 2 over 2 plus root 2 over 2. That's going to be 2 plus root 2 over 2 over 2. Now keep, change, flip. 2 plus root 2 over 2 times, flip that. It becomes 1 over 2. So it becomes 2 plus root 2 over 4. All right, reduce all that. Reduce all that by, or can I reduce it? I don't think I can. I can't reduce it because I can't do anything to that square root of 2 because it's underneath the square root. But I can rewrite it as the square root of 2 plus root 2 over the square root of 4. And the square root of 4 is just 2, so it's the square root of 2 plus root 2 over 2. Boom. Now, hopefully that's right. Let's type that stuff in and see. Square root 2 plus root 2 over 2. Correct. Yay. Good deal. All right, let's skip around a little bit. Let's go to number, let's say 6. All right, I see an identity to do this. This is cosine squared 30 minus sine squared 30. And I can see there's an identity right here. That's cosine squared alpha minus sine squared alpha. That is the same thing as cosine of 2 alpha. That's a double angle identity. So this is the same thing as cosine of 2 times 30 then, which is cosine of 60. Now if I remember my special triangle correctly, cosine of 60 is 1 over 2, and that should be the answer. Okay, 1 plus cosine of 8 over 2. Match the expression with its equivalent expression. I am thinking that this has to come into play. 1 plus cosine alpha over 2. All right, so let me write that. Cosine alpha over 2 equals plus or minus the square root of 1 plus cosine alpha over 2. So if we use what our numbers here, and I put it right, put the 8 right here, right? That's going to be plus or minus the square root of 1 plus cosine 8 over 2. All right, but I don't want the square root on there. Equals cosine of 8 over 2. So if I don't want the square root on there, if I want it to match this, then the way I can get rid of it is to square both sides. Okay. So if I square that, then that gives me this right here, this expression right here becomes cosine squared, and the 8 over 2 just reduces to 4, so cosine squared of 4. Right, we're squaring the cosine of the angle. 8 over 2 is 4, so you just square that. So it's just cosine squared of 4, and let me see if that matches an answer choice. Cosine squared 4. Yep, it should be choice C right there. Correct. Let's go to number 13. All right, looking at number 13, I think this is the approach I'm going to take. I'm going to use this identity right here. That looks like it has a chance of matching something I'm trying to do up here. Now, what I'm going to do is I'm going to take this and I'm going to factor it. That's a difference of squares. It's like a squared. I'm going to write that. A squared minus b squared factors as a plus b, a minus b. So if I use that same thing for this, I can factor that expression as cosine squared theta plus sine squared theta times cosine squared theta minus sine squared theta. See what I'm saying? Because it's cosine to the fourth of theta is a perfect square. Sine to the fourth of theta is a perfect square. The perfect square root of cosine to the fourth is cosine squared. The perfect square root of sine to the fourth is sine squared. So this factors is cosine squared theta minus sine squared theta plus, cosine squared theta plus sine squared theta times cosine squared theta minus sine squared theta, which is what we did right here. Now, what is cosine squared plus sine squared? We already know what that is. That's a Pythagorean identity. That is just the number, the good old number 1. So we're left with that. So cosine squared theta minus sine squared theta equals cosine 2 theta. And there's the identity. That's the same thing as that right there. So done. Now I just got to pick the right answer choice. I'm liking choice C. And choice C it is. Good deal. All right, on to 6.5. Product to sum identities. 6.5. Sine alpha cosine beta equals this thing. So let's use that to solve this problem. So this is equal to 1/2 sine I think I'm looking at it wrong. It's both. Okay. Which one does it work? Which one works? Sine alpha sine beta. Sine alpha sine beta. Where's that one? That one's right here. So it's equal to 1/2 cosine of alpha minus beta. That's 15 minus 2, that's 13. Plus cosine of alpha plus beta, so that's 17. I think there may be a misprint right here when I typed all these up. I think that plus is supposed to be a minus. I think that is supposed to be a minus. So I think this should be a minus right here, and I need to correct that on the identities sheet that I put on Moodle for you, and I will correct that and get that to you, get that put up on Moodle corrected tonight. All right, let's skip ahead to number 6. Sine alpha cosine beta looks like we could use this guy. Hopefully, let's see what happens. So this is equal to 1/2 sine of 11 pi over 24 plus 5 pi over 24 plus sine of 11 pi over 24 minus 5 pi over 24. Okay, let's see if we can work this thing out. So 11 plus 5 is 16. So that's 16 pi over 24, which reduces to, if we divide them both by 8, 2 pi over 3. That's one of our special angles, so that's great. 11 minus 5 is 6 pi over 24, which reduces to pi over 4, which is also one of our special angles. That's also great. So we have 1/2 sine of 2 pi over 3 plus sine of pi over 4. Sine of 2 pi over 3, that's the same thing as sine of 60. So it's 1/2. Sine of 60 is √3 over 2 plus sine of pi over 4, that's √2 over 2. That's sine of 45, √2 over 2. And we can have ourselves a common denominator here. So this can become, we get kind of out of room, so I'm coming up here. 1/2 times 3 plus √2 over 2, which becomes 3 plus √2 over 4 when I multiply these two things together. And that should be my answer, 3 plus √2 over 4. Let's type it in and make sure. 3 plus √2 over 4. 3 plus √2 over 4. It says it is incorrect. I think I know what I did wrong. 2 pi over 3. 2 pi over 3. 2 pi over 3 is 60. Pi over 3 is 60. 2 pi over 3 is actually 120. But sine of 120 is the same thing as sine of 60, because we got quadrant 1 and quadrant 2, and sine of both of those quadrants is still positive. Now I see my error. Maybe some of you guys saw my error earlier, but now I'm just now seeing it. This is a square root 3. Look right there. That's a square root 3. When I rewrote it up here, I didn't put it as a square root 3. I just put it as a 3. It's supposed to be the square root 3. Why didn't y'all tell me that? Doggone y'all. Supposed to tell me these things. Supposed to reach through the computer and say, hey, look at the square root missing right there. Oh well. Now let me retype it in and hope that that is the only error. Should just be a square root 3 right here, and that should fix the problem. And we hit enter, and we see the green check mark, and we celebrate. Yay. Let's go to question 11. See what it looks like. It looks like we got a cosine alpha minus cosine beta, which looks like it should be this identity in being put to use. I'm also going to use the fact that the even identity, which is the fact that cosine of negative alpha is the same thing as cosine of alpha, using the even function identity. So let me rewrite it as cosine of 41 pi over 24, because that's the same thing as negative, the cosine of negative 41 pi over 24, minus cosine of 47 pi over 24. That's going to equal now negative 2 sine of 41 pi over 24 plus 47 pi over 24 over 2 times sine of 41 pi over 24 minus 47 pi over 24 over 2. Man, this thing's going to be complicated, isn't it? All right, let's do it. 41 plus 47. That's 88. That's 88 pi over 24. Well, if I divide both of those by 8, that reduces to 11 pi over 3. And 11 pi over 3 is one of my special angles. I think I can do that. 11 pi over 3 is, where would that be? If I go all the way around, that's 6 pi over 3, because it's 2 pi. And if I go 6, I go all the way to here, that's 9 pi over 3. And if I go all the way around here, that's 12 pi over 3. So 11 pi over 3 would be right in here. 11 pi over 3 with a pi over 3 reference angle, which is a 60-degree reference angle. So, but we got to cut that in half, right? We got to divide it by 2. Should have done that already. So I need some room. So that's equal to 11 pi over 3. This becomes 11 pi over 3 divided by 2, which is the same thing as times 1/2 when you keep change flips. So that's 11 pi over 6. 11 pi over 6. Now let's think about where that thing is. All right, 11 pi over 6. Pi over 6, I know that's going to be a 30-degree kind of angle. So if I go around here, that's 6 pi over 6. If I go all the way around here, that's 12 pi over 6. So I back up by pi over 6, and that puts me right here. Okay, and there's your pi over 6 reference angle. So that's 11 pi over 6. And so I'm talking about the sine of that angle. So that's 30 degrees. Sine of 30 is 1/2. 1/2. But it's going to be a negative 1/2 because sine in this fourth quadrant is negative because it's the vertical component. And the vertical component down here is negative. So negative 1/2. So negative 2 times negative 1/2, I believe. That finishes up that part. Now let's work on this part. 41 minus 47, that's negative 6 pi over 24, which reduces to negative pi over 4. Now divide that by 2, which is the same as multiplied by 1/2. That's negative pi over 8. And now I think, all right, this is very complicated. I think I'm going to use this half angle identity. Sine of alpha over 2 equals plus or minus the square root of 1 minus cosine alpha over 2. Sine of alpha over 2 equals plus or minus the square root of 1. Can't remember. Minus cosine alpha over 2. Okay, I'm going to have to use that, I do believe. I'm also going to have to use the odd function identity because this is now sine of negative pi over 8, which is then going to become, by the odd function identity, the same thing as negative sine of regular pi over 8, which is going to be negative. I think that what I'm going to do with that negative, I'm going to go ahead and erase that negative and apply this negative over here and make this become a positive 2. So now I don't have to worry about the negative anymore. So it's now sine of pi over 8, which is the same thing as plus or minus sine of pi over 4 over 2, which is plus or minus, I shouldn't put that there, but square root of 1 minus cosine pi over 4 over 2. All right, we're getting there. We are getting there slowly but surely, which is plus or minus the square root of 1 minus pi over 4, the same thing as 45, so root 2 over 2 over 2. And that can be 2 over 2, so that becomes 2 minus root 2 over 2 over 2, which is over 2, I'm going to say plus, I'm going to say times a half, which is 2 which is 2 minus root 2 over 4, which is the square root of 2 minus root 2 over square root of 4, which is square root of 2 minus root 2 over 2. Golly, that was rough. Wow. Now, what does this become right here? This becomes 2 times negative a half becomes negative 1. So it should just be this minus 1. That should be my answer. Now, I am very worried about typing that in. Very worried indeed. Because that took a lot of effort, and it's certainly a chance that I could have made an error somewhere. But I'm going to type it in. Alright, I just typed it in. I'm hitting enter. It says I am incorrect. I think I see my error. And it is that these two things are not added together. They're multiplied. So, I shouldn't have subtracted 1. I should have multiplied by negative 1. Let me go back to the drawing board just a tad bit over here. This should have been not, again, I think all this may be right, but this should have been multiplied by negative 1, not added with negative 1. This should be multiplied, which just means we just have a big negative sign in front of this. And that should be all that it takes. Let's type it in now again and see. And say a prayer. Let's just go in front of this thing and put a negative. Hooray! We got it right. All right, as you can see, some of these problems are pretty darn tough. A lot of them are pretty darn easy, but they can be pretty tough. But don't worry, just do your best. And if you can't figure some of them out, ask me about them in class. I'll help you, and we'll get through it. And I hope you, again, as you get more experience, and as we all get more experience at this thing, we get a little better at it. Good luck with this assignment.